Hello, calculus students. It's me. All right. This is our function f. This is f. You are going to sketch f prime. Now, this one right here is probably much more difficult than most of the ones on the homework assignment today, and just in general. The big thing we need to remember here is f prime is the derivative. F prime is the derivative. The derivative finds the slope. So we're going to find the slope here. Find the slope of this function at all of these points, and we're going to that slope is going to be the y coordinate. All right, that slope is going to be the y coordinate. So right along here, all these slopes right here, there's no slope, so it's 0. So all along here, slope does not exist. It is 0. Now right here, you notice the slope is 0, but then it starts kind of moseying on up. So what do I do here? Well, if the f is increasing, when f is increasing, we know f prime is going to be positive, because the slope along here is positive. That's a positive slope. That's a positive slope. So just a reminder, when f is increasing, that results in f prime is greater than 0, or positive. So right along here, well, over the course of these two blocks, I went up 1 over 2, right? So I could say slope right here looks about a half. Okay. Up 1 over 2, so slope right here should be exactly like, we'll call it 1/2. Right here goes up 1 over 1, so right in here, probably like right there, the slope is going to be 1. That's the slope. I know I'm going like, it's not quite here, but up 2 over 2, that's about 1. Make it a little bit less since it's down here a little bit. So just slightly under that. Right here. Now remember, we can use the secant line to approximate. So what's the slope from here to here? Well, it's going to be up 1, 2, 3, 4 over 2. So it looks like right in here, it's about 2. You can even go break down even farther. Right here, 1, 2, 3 over 1. So this looks like the slope right here is 3. Then from here to here, up 1, 2, 3, 4, 5 over 2. So 2.5. Well, it looks like it's decreasing here. Right here, I'm going up 1, 2 over 1. So right here looks like the slope's going to be 2. This halfway point right here, if I use these points around it. From here to here, we're going up 1 over 1. Looks like the slope is going to be, if I go right in here, it's going to be 1. If I do the points around, if I go for right here, right here, up 1, 2, 3 over 2, that's 1.5. So what I'm doing is I'm kind of going, using the points around it, and I'm also kind of going halfway in between. Now right here, you can look at this and say, hey, right there, that's a maximum. There's a maximum. It's a relative maximum. The slope, you know the slope's got to either be 0 or undefined. Well, this one, the slope is just 0. Right there is 0. Then for right here, let's calculate the slope right here. going down 1 over 1. So that looks like -1. Doing right here. And again, we're just approximating. This is just a sketch. So there's -1. I want to do this one, I can use the points around it. So down 3 over 2, that's -1.5. If I go in here, it's down 2 over 1. So that's -2. If I'm trying to do this point now, I'm going to go down, use the points around it. So here and here. Here and here. Find this slope. Down 1, 2, 3, 4, 5, 6 over 2. So that's a slope of -3. If I go in between this one, use the points around it again. Down, oh, not there, it's right there. Down 1, 2, 3, 4 over 1, so it's a slope of -4. So the big thing here is I want you to see that to find the slope, we're going to estimate by using the points around it. Use the points around it, that'll estimate the slope right there in the middle. We've talked about this, and that's okay. Going from here to here, we're using points around to estimate this slope. So from here to here. And then because sometimes it's just nice to go right on whole numbers, I'm using, again, the points around it. So from here to here, estimate this slope. I'm going down 1, 2, 3, 4, 5 over 2. So that's -2.5 now. So it's right here, going down 1 over 1. That'll estimate the slope for right here in between. Down 1 over 1, so it's going to be -1. Right here, use the points around it. And this is where we can get in trouble. Got to be careful. If I look at this, though, that's flat. So that means that's going to tell me the slope right here is 0, actually. But then you'll notice it starts going down again. Went down 1 over 1. So right here in between, because it's going down 1 over 1, that's -1. For this slope, I'm going to use points around it. Here to here, it's -1, 2, 3, 4 over 2. So that's going to be -2. Right here, 1, 2, 3, 4 over 2. 2. If I go here, though, it's -1, 2, 3 over 1. I'm sorry. Yeah, that's fine. Right here, though, once again, we're going to see that. So down here, it's down 1 over 1. That's negative. Here, though, we know that's a horizontal tangent, so the slope's got to be 0. Now suddenly, oh my gosh, we're going positive again. If I go right here, use points around it, go up 1 over 1. So slope right here is going to be -1/2. To go around this one, it's 1, 2, 3, 4, 1, 2. Slope right here looks like it's going to be 2. And that's kind of how we start graphing our derivative. The big thing I want you to realize here is, again, I'm just using points around it to get the y coordinates. This is just a sketch. It's not going to be perfect, and that's okay. Key things to look out for, though. F is increasing, f prime is greater than 0. You'll notice f is increasing all the way up here. Look at the y coordinates here. They are all bigger than 0. And you might say, but Mr. Kuhne, it's going down right here. Yes, it is. But the y coordinates are still greater than 0. F is increasing because the y coordinates are greater than 0. All through here, you'll notice F was decreasing. F is decreasing. That results in F prime is less than 0. Or negative. And you'll notice right through here, all of these values were negative. They're all below the x-axis. The y values are negative for F prime. This is my graph of F prime. Right here was 0. We had a horizontal tangent. Then, looks like it probably did something like this and started coming back up. Again, right here, F prime, there's a horizontal tangent. That minimum, F prime was 0. Horizontal tangent, F prime is 0. And you may be saying, what about over here, Mr. Kuhne? What's going on over here? That's a good question. Right through here, you'll notice slope is -1, -1, -1. Slope's going to be -1 all the way over to here. Does the derivative exist right here? It does not. It's a sharp point. So I'm going to leave that open. From here on, you know, the slope is 1, up 1 over 1, up 1 over 1. So I'm going to come up here, leave it open because the derivative does not exist there. And I'm going to draw that line all the way over to here. Once again, sharp point. It's not curving, that's a sharp point. Does the derivative exist right here? No. So I leave it open. And from here on, it was 0. Then some of you are going to argue, should this be open or closed at the end? It should be open because you can't take the derivative at the end right there. So, some key points I want to make here in a different color. Ways to check yourself. If you see a horizontal tangent, either like this, this, or this. If you see a horizontal tangent, at these points, F prime is equal to 0. The y coordinate on F prime is 0. If F is increasing, F prime is greater than 0. In other words, it's above the x-axis. F prime is above the x-axis. If F is decreasing, like it was through here, F prime is below the x-axis. You're going to say, Mr. Kuhne, that's a really ugly derivative. Yes, it is. Yes, it is. But we're just sketching here. We're trying to get an idea of what's going on. There are ways we can smooth this out later. And I just want to make sure that you get this whole idea of if it's increasing, it's above the x-axis. F is above the x. If F is increasing, F prime is above the x-axis. Horizontal tangent, it's 0. If F is decreasing, it's below the x-axis. We have that horizontal tangent right there. And how do you estimate the slope? You use points around it. Maybe you just use the endpoints, 2 coordinates right here, or maybe you use these right here to estimate the derivative right in between. All right? Hope that helps. Good luck on your homework. Stop in for office hours if you have any questions. or you can send me an email. We can meet, and I will try to meet with you. We can set up a time if my office hours don't work. Anyway, thanks for watching. Hope you have a great day. Yay, math. We're going to get through this. Bye.